And one of the great mysteries of the cosmos, dark matter, that invisible stuff that our prevailing theories suggest should comprise 5/6 of the known universe, but that just doesn't seem to be hiding anywhere. Until now, perhaps. Theoretical physicist Christian Beck at Queen Mary University of London thinks he may have stumbled on what dark matter is. Jacqueline, do tell, solve the riddle for us. What does Beck think he's discovered here?
Right, exactly. So what he thinks was found was in 2004, there was an experiment that was going on, and it explored kind of the noise levels within a junction, and there were these mysterious signals that were detected. And so what we think these signals were, and if we can prove, they might have come from what's called axions, which are a component of dark matter, and therefore we may have detected dark matter without even knowing it. Now, of course, more tests need to be done to confirm this, but, if he's right, I mean, how crazy is that? We may have come across it without even knowing.
So, Tim, these are particles that whose existence we already knew about, but we just weren't aware that they were dark matter? Is that what this guy's saying?
No, these are particles. These are theorized particles, and they're actually a particle that comes from string theory. But it's a theorized particle that no one's ever observed before, and the reason would be because, I mean, the previous understanding of dark matter was that it didn't interact with anything except through gravity, and there was really no way to see it. So that would be the worst case scenario, is just that there's really no way for us to see it except in extremely large quantities where it bends the galaxy and lenses light and stuff like this. But the hope here is that there actually is some sort of interaction. If you get enough of these axions together in sort of a condensed state, then there are actual experiments that we can do. That's the hope, and I guess perhaps there's evidence for it.
Well, the reason I suggested there was evidence for it is because in the article it says that if the idea is true, then Beck says that evidence may already have appeared in a 2004 experiment, which was exploring noise levels in SNS Josephson junctions. I love how esoteric this stuff gets. That revealed a signal of unknown origin, and he's speculating that could be these axions, and that maybe over the next few months or years we should be able to detect differences in the levels of these axions, which would correlate with going through areas of the universe that have more or less dark matter. And if there is a correlation, then his theory could be confirmed.
Well, not more or less dark matter, but what happens is as the world goes around the sun is also going around the galaxy. So when the Earth is going in the same direction that the solar system as a whole is moving, you're moving faster through the cloud of dark matter, and you're going to get more interactions. And then as you move around to winter, you pull back, and it's sort of you go through less of it because you're going backwards as the sun is going forwards. So if this is true, what we should see in this noise is an oscillation on a yearly period that shows peaks in the summer and falls in the winter. And if we see that, I would say that's pretty good evidence.
James, with regard to your earlier comments about how esoteric this stuff can get and how speculative it sort of is in comparison to someone who actually works in practical fields of science, dark matter, the fact that we need an explanation for this stuff, that we need to make up this stuff in order for our theories to work, even though we've never seen this stuff and there's no evidence that it exists apart from the fact that our theories don't make sense without it, does sometimes make me wonder, maybe it's our theories that are wrong and maybe the dark matter isn't there.
Well, in this case, I think it's great to really pose these things because there's an emptiness in the knowledge. We have no idea. But for me, I look at everything like a brain in a skull, whether it's the brain in the skull or the Earth surrounded by an atmosphere or the universe surrounded by the so-called surface. For the dark matter, much of what we know now about the brain, the electrophysiology, energy in the brain, was really dark matter before this past century. And it wasn't until we realized that we had to shield the recording, the actual electrical recording. Well, they have the same problem here with the dark matter because these axions, there's no way to shield them. And the shield is called, it's something that keeps out the noise. And it was funny listening to the noise explanation in the article. We had a thing years ago when we They were called PGP, patent garbage potentials in the brain when you're recording from cells. And we thought there was some sort of signal there. And it was just a garbage potential. And it was due to people like opening and closing the lab door, things like that. So you got to, but as long as the theory's out there, these are great to have because you got something to work on.